I'm Prudence Ferreira. I'm a senior member of the Carbon Neutral Design Group at BR+A Consulting Engineers and lead their Passive House team. For those of you who may not know me, I've been doing Passive House consulting for over a decade and focus primarily on large-scale Passive House and streamlining and standardizing passive house workflows for fast-paced projects. And each Wednesday night with all of you, I learn something. And that provides fuel and inspiration for my work. So thank you all for being wicked smart, as they'd say in my new home of Boston. My co-host Monty, he's taken some time off. He'll be back with us in a couple of weeks, but if you scan the audience, he might pop up. So now to kick off the fun, I'd like to invite you all to unmute yourselves. If you haven't already, raise a glass. And tonight I'd like to toast to 3 things. Number 1, failure is a teacher. And that means our failures teaching us, yes. Number 2, the freedom and courage to change one's mind based on lessons learned. And 3, doing things better the second time around. Here's to that.
Cheers. I like that.
Words to live by.
Well done.
Number 2.
Timely for our second happy hour of the year. All right. So now mute yourself and fasten your seatbelt because tonight we have another great show. Last week we had 3 incredible minutes of Zen with our video of a gorgeous mass timber passive house residence in Western Canada designed by Perkins and Will. And this week, we get to watch more of that video and hear all the fantastic details and lessons learned from the project architect, Cillian Collins. We're also going to be joined by the homeowner, I hear, for the first hour. So if you have questions for him as we go through the presentation, be sure to get those in early before he leaves. So now let's have another look at this iconic passive house project.
The remote nature of the site led the project naturally towards prefabrication and modular construction methods. This allowed the panels to be built off-site in the shop during the winter months and then to be erected quickly on-site during the shortened building season. We designed Solo to have a performance-led aesthetic. It contains a limited material palette and contains architectural features that are authentic and unsentimental. The building sits on a raised platform above the uneven terrain of the site. It touches the ground lightly and allows nature to remain the focus. As you walk up the front steps, the covered walkway frames a view to the mountains beyond. Wood was chosen as the primary structural material. It was the obvious choice to reduce our carbon footprint, but it also provided flexibility for the prefabrication of the modular panels.
The temperature in Sioux Valley can get below minus 30 degrees Celsius in the winter and can reach levels above 30 degrees Celsius in the summer. So given these climate extremes, ensuring that the occupants are warm and comfortable in the winter and then adequately cool in the summer is very important. So as an off-grid system, the building must be self-sufficient. Designing a high-performance building enclosure using passive house principles reduces the need to rely on complex mechanical systems. This results in a more resilient building, irrespective of outdoor temperatures or in the result of extended power outages. Thermal comfort is guaranteed through a thick 2-foot layer of mineral wool insulation that wraps the mass timber structure, in addition to high-performance triple-pane glazing systems. Detailed thermal bridge calculations are carried out at design stage, and an air tightness blower door test is done at construction stage. These measures minimize heat loss, eliminate drafts, and reduce the risk of condensation buildup. The glazing design is optimized to maximize views to the valley outside and promote daylighting, while allowing sun in the winter and eliminating solar gain in the summer. A high-efficiency heat recovery ventilation system ensures a constant supply of fresh air, while recovering waste heat from areas like the kitchens and bathrooms. Natural ventilation is used for cooling in the summer, with windows judiciously sized and placed to promote cross-ventilation. The small heating demand in winter is provided for by a radiant underfloor heating system. This is fed by a ground source heat pump that uses energy from the sun that is stored in the ground as heat. Energy is generated on site through the use of 103 solar panels mounted on the south facade. The vertical mounting allows the PV system to remain clear of snow in the winter when energy generation is crucial. The PV system links back to a set of batteries which store the energy generated. Being an off-grid site, we need a backup power source. This is provided for by the hydrogen fuel cell. This means that the building does not consume fossil fuels, nor does it require combustion to operate. This results in a self-sufficient house that generates more energy than it uses and goes beyond net zero energy. It tackles both embodied and operational carbon and creates an innovative model for buildings in the face of the climate crisis.
Fantastic. Awesome. Can't wait to hear more, Cillian. Okay, so we are going to go into breakout rooms now for about 5 minutes. So 5 minutes goes quickly. Make sure you get a chance to go around your room and do some rapid fire introductions. And we will see you back here shortly. Welcome back from the breakout rooms. I'm going to do some quick announcements, and then Prudence is going to make the introduction of Cillian. So every week at the Passive House Accelerator, we produce a Passive House Week in Preview article on Monday. And so this is this Monday's article. And you can see there was a great construction tech last night. We'll have a video of it available in a few days. And then here we have tonight's show. Lois Arena of Stephen Winter Associates is featured on this week's episode of the Passive House podcast. She'll also be presenting at the happy hour next week, and I'll talk about that a little bit later. We've got some great Passive House and building science gatherings coming up this week, including Brandon Weiss of Devel, based in San Diego, prefab stuff at BS Fridays, and these other and building conversations with Chris Ballard from Passive House Canada is getting going again for 2021, and then all sorts of educational resources here. So please check those out. And I think that's it for me. So Prudence, please take it away.
All right, so I have the honor tonight of getting to introduce our featured guest, Cillian Collins. I got to meet him when I was up in Vancouver. I miss Vancouver. He's a senior architect with Perkins and Will, and a certified passive house designer with over a decade of experience across a range of different project types, including passive house projects in Canada and in Ireland. He's also the chair of the Passive House Canada Education Committee, playing a big role in curriculum development there, teaching and advocating for PH standards in Canada. And with Perkins and Will, he's involved in their Passive House projects, varying scales. One of them is an off-grid mass timber cabin. We might be hearing about that one. To a large-scale university student housing project. And he's also a proud daddy to a little fellow who is just getting his legs under him and starting to walk. So thanks, Cillian, for all you do for his generation and for our community. And thanks for joining us tonight.
Thank you, Prudence. Appreciate the introduction and the invitation to present. So let me just share my screen.
Yes, looks good.
Okay, super. Talking about this project that I guess was featured in the video, which we made recently for the Passive House Canada conference. Kirk, who is with Delta Group, is also on the line, and I guess I can introduce him a little bit towards the end. But Kirk obviously was heavily involved, being on the client side and shepherding this project through. Internally on our own team, I won't take credit as being the project architect. I was involved with the project, but we had a great team. Alicia, who was featured in the video, and also Ike, heavily involved, and then Derek, who I think is sitting quietly in the background of this call, was our principal in charge and led and oversaw the overall project. And then even though it's a small single family project, And we don't typically do single family housing. We typically do larger projects. We had a full consultant team because it's being used as a prototype for some larger projects. So I do have a number of slides, but I'll be going through them relatively quickly, and we'll have plenty of time for questions. So most people on the call, or I guess everybody on the call, will realize the compatibility between Passive House and mass timber, with Passive House tackling the the operating carbon footprint, and mass timber dealing with the embodied carbon footprint. So that's what this project and many of our other projects set out to do. And there's overlap in terms of how they gel or work well together. This particular project, as I mentioned, serves as a prototype for a number of larger projects that we're working on with the same client and consultant team. So with Delta, we're currently having finished what we call Solo, or the Sioux Valley timber cabin that we'll be talking about. We're also working on a 6 or 8 story, an 8-story mass timber Passive House residential project, which is going to development permit at the moment. And I'm just going to move my notifications because they're bugging me. And high-rise project as well, currently in rezoning in Vancouver. The cabin itself, as mentioned, is in an off-grid location in Sioux Valley, so north of Whistler, between Whistler and Pemberton, a really remote and really beautiful location. So part of the project mandate was to celebrate its location and its beautiful area. An idea of where it sits in terms of geographic and climate context. In PHVP, it's a cool temperate climate, a GT of about 90 kilokelvin hours per annum. So it is it does get pretty cold in winter, not as cold as further north in Canada, but still pretty cold. It sits in a valley, so there's mountains on both sides. So when we look at some of the Passive House metrics, we do get penalized by this large mountain to the south. It's about 1.5 kilometers away, or I guess a mile for those of you who are imperially inclined, and about the same distance high. So it has a significant impact. The approach to the project, as Alicia had explained in the video, was to keep things simple. So creating a level platform, raising the project off the ground, minimizing the footprint, and then building a mass timber enclosure and wrapping that with mineral wool and putting a shield or a shelter underneath. We also aim to keep our material palette pretty simple, not having wet trades on site, minimum amount of materials, and also sort of that was the architecture aesthetic that was sought after. So only 6 handful of materials on site. Programmatically, I guess, this raised platform also has a mechanical sort of sub-level, the only part that touched the ground, and then 2 levels of accommodation, living and bedroom accommodation, and adhering to Passive House principles, keeping the shape as simple as possible, and then window to wall ratios, R values, etc., that everyone's familiar with. This is an idea of the floor plan layouts. I won't dwell on them, but you get an idea, and I'll be talking a little bit more about certain areas in particular. So our mechanical basement, for want of a better word, originally placed there because we had, being off-grid, we thought we may need a composting toilet. But it just made sense to house things there. It does impact our form factor, so that was a consideration. These 2 small portions here are outhouses. They're still insulated, but there's a sauna and a storage room. They're not part of the thermal or Passive House enclosure. Here's an idea of the finished product as we go through. So just to touch briefly on the mass timber aspect, as Alicia, I think, mentioned in the video, it was being in BC, it was seen to be, I guess, a temple of Douglas fir and celebrate wood and mass timber. With that comes the carbon footprint or positive benefits associated with that. So managing to reduce the embodied carbon within the structure, and then also sequester or store carbon over the lifetime of the project. And part of that, reducing the material palette, using the structure and finish as one, not having drywall or anything in addition. There's a variety of types of mass timber in the project. So the main floor structure is NLT, or nail laminated timber, and the walls and roof is DLT, or dowel laminated timber. And then the main floor or second level floor is CLT, or cross-laminated timber. And then we do have an outer, I guess what we refer to as a shield in the drawings, that are glue lam beam and columns. So that creates this idea of, I guess, the just using mass timber in its and timber in its purer form. A couple of things you'll notice, apart from all the timber in this video, is I guess concealing services. When you are exposing that much timber, you have to pay particular attention. It is a and I guess this was particularly coming from I remember Derek saying this, we do have to sprinkler these buildings, even if it's a Part 9 building. So there is sprinklers in this building. So how do we conceal that? Stuff like the ventilation shafts are concealed. So you really have to pay attention to that level of detail. Large windows to the south to let in or maximize winter solar gain. So these are up-to-win windows, and the window behind where this photo is taken is a Ryco curtain wall, both Passive House certified. You might ask, how can you get away with a double height space in a Passive House building, particularly a Part 9 building? You can't. And the reason why we can get away with in this building is, and we'll talk about this in a little bit more detail, is this building achieved Passive House PHI low energy certification. So it missed the 15 kilowatt hour target for space heating, primarily due to the mountain to the south. And as we were treading that line on and off for 15, we had to decide if we were going all the way or if we wanted to reintroduce stuff like the double height space and the glazing to the northeast. We still wanted to go through and certify and adhere or follow through with the third-party certification, as we see that as being important. So this is a snapshot from the PHPP model, or at least a plug-in to PHPP. So you can see the heating demand consistently hovered about 18 to 22 kilowatt hours per annum, primarily driven in a single-family building. You want your solar gains to be higher than your window losses. And we were always fighting the lack of solar gains due to the mountain to the south. We went through, and we'll look at a little bit more detail, modeling all our thermal bridges. We have thick envelope enclosures, so you get negative psi values, so that becomes a benefit. We could look at reducing our window losses, so eliminating or reducing this large northeast facing window, filling in the double height space, but we were still just on that line at around 15 or 16 kilowatt hours. We could never get our solar gain to increase. So that was sort of it's that overlap between design and performance. Sometimes the two go in hand, and sometimes they're a little bit divergent. So what we looked at in order to hit the full certification, we're filling in the double height space, removing or reducing that northeast glazing, rotating the building is slightly off south, oriented to the valley, so we could reorient it a little bit more due south. We could tweak specifications, like in PHPP, you can change what's called the wind coefficient. We looked at vacuum glazing, quad glazing. We could ask the tradesperson or the contractor was quite experienced, so we could ask them to hit a lower air tightness value, look at better window installs, etc. We looked through these at various times, and it seemed to be chasing just a little bit diminishing returns. We could never get down comfortably, say, within 10 or 12 kilowatt hours where you would want to be really going on site. Which is maybe somewhat unfortunate for the project, because if we were within that range, we would probably comfortably have been a Passive House Plus project, given the amount of PV. But we're still happy and delighted to have Passive House low energy certification. As part of the process, we have internal research grants. One of them we used for trying to find a way to export from Revit through various programs to get a more automated system for developing thermal bridging. Anyone who's used Term, and I know there's better programs now, but at the time Term was the only thing really freely available. It's a nightmare to use. So we were spitting it out of Revit into Rhino using Grasshopper and trying to get our psi values. But that we did model and get the benefit of all our negative psi values with our large envelope corners, etc. So these are the three main sort of performance blockers, I guess. The mountain solar gain. So we model this in different ways, again in Rhino and Grasshopper. Our certifier modeled it using Design PH. You can model it in PHPP just with a flat horizon line, but there was no overcoming the fact that it was there. And again, the double height space and glazing are more design decisions that sort of ebb and flow. You can push them all the way towards the performance dial, or towards the, I guess, more architecture dial to see where you land. And this is where we end up. And in addition to being a single family house, the mandate from the client was to have somewhere to bring their own clients, or to host like networking events as well. So this central space is quite important, excuse me, important from their viewpoint. And Kirk can maybe talk a little bit about that. So we achieved our certification. This is the first passive house certification within Perkins and Will. We have a number of other projects on the go at the moment, so that's an important milestone for us. Excuse me, as I just take a very quick drink. Sorry, I better speed up a little bit. So just getting a little bit more into systems. We saw in the video the PV panels. So the south facade, instead of having a rain screen cladding, has a PV system that generates electricity on site. It's mounted vertically. You lose a bit of efficiency having it mounted vertically because of the snow, but because of the snow load, if you put it on the roof, you'd have to clean it off, and being an off-grid house, that's maybe not the most practical. So we took the efficiency hit and mounted it vertically. And it means you don't need a cladding. This is an idea of some of the detailing at that level. So the grid is set out based on mass timber CLT panel modules and this solar panel module. And you can see a idea of the air tightness, the thickness of the assembly, how the window is installed. You can see some service routing left for, say, sprinkler lines and additional stuff like that. I'm not going to dwell too much, but the finish, I guess, in the end is nice and clean. This is an idea. These are shop drawings from BC Passive House, who fabricated it. So because it's a pretty small project, I guess, they did have to plug in a lot of gaps between the panels. You get an idea there. This is an idea of erection. Their factory is just up the road in Pemberton. And because of the weather, I guess, we didn't really want to be on site in winter. So the prefabrication nature of the project helped it to be assembled pretty quickly on site. I talked about the systems in the video, so I'm not going to dwell too much on that. We have the typical HRV, we did drill a well, we have a ground source heat pump feeding the radiant underfloor system, and then the battery, the PV is tied to a battery pack. Which there's always an overlap with an off-grid system. Are you aiming for peak or average use? If you go for average use, it's less expensive, but then you have to make up the balance. So that then is where the hydrogen fuel cell come into play. You need somewhere to put them. So Derek and Ike designed what's probably the most beautiful shed. A nice sort of outhouse to house all the systems that are associated with it. So the hydrogen fuel cell and the battery packs sit in there. So that means the project itself is emissions free. There's no combustion on site and no greenhouse gas in operation. So I'm conscious of time. Zach, am I okay to keep going? I don't have too much more, but I'm just going to roll through.
Oh, thanks for asking. Yes, please do.
Okay. So just a couple of lessons learned as we scaled up before we wrap up with quick questions and answers. So as we look into the larger projects, there's a couple of lessons learned for us internally in terms of our systems, in terms of our processes and just design. So this is an idea of the 6-story project. This is in West Vancouver, and this is then in downtown Vancouver, undergoing rezoning. We're looking at, in terms of energy systems, can we scale up the idea of PV panels, batteries, and hydrogen as a system? Anyone who attended the PHI conference might have seen a German manufacturer or system that has all these packaged in one, where the surplus from the batteries actually goes into the electrolysis of the hydrogen, which is quite interesting because our experience maybe on this, it wasn't quite as streamlined because these are all coming from different manufacturers and didn't quite always talk to each other. So that's a consideration. But can that be scaled up? A project typically has a backup diesel generator. And this is more of a thought experiment. We're just looking at it at the moment without, we haven't necessarily gone too much down the line, but there is some, I've come across some research as we get into low carbon grids that rely on renewable electricity, that buildings become what they call prosumers, as sort of a safety valve to both produce and store electricity. So I'm not going to dwell on this, but we have we're looking into this in a little bit more detail at a larger scale. In terms of our internal modeling process, we have a large student housing project at the moment that RDH are external consultants and passive house modelers on. The Sioux Valley, we did our own internal PHVP, so there's a balance there between whether that scope is internal or external. There's benefits to both. For Bellevue, we're early stage at least doing the internal modeling to validate our design decisions. We work a lot with Revit and Rhino. So we're trying to figure out, is there a way to implement PHVP into some of that process is. And we have quite extensive computational modeling processes at the moment using Rhino and Grasshopper. So trying to plug PHP into that. And others have done, like Ed May, who presented on this at the conference recently, has done work on that. So we're looking at that at the moment, which would help just our internal process. And then just structure, I touched briefly, Glatman were structural engineers. This was a gravity bearing, sort of just CLT panel and bearing walls. As you get larger, there's some different considerations. You move to a panel and post for mid-rise, and then a panel and beam, or a post and beam with infill panels as you move to larger buildings. So that just comes with different sort of dimensions for grid layouts and sort of structural decisions as well. We're doing mock-ups for the larger buildings on cladding and also on thermally broken timber high-rise balconies as well. So this is in process too. But then for a passive house building, it just comes back to the environment and then the comfortable indoor environment. And I think that's essentially what you're getting regardless of the scale. So that's what I think everybody is after. Particularly in where we are, we just wanted to celebrate the place and have a nice, comfortable sort of environment to enjoy where we are. So, and I think hopefully that's what the project has resulted in. So I think from there, I think we can wrap up and move on to any questions or comments. I'll also, I guess, welcome Kirk, who is with Delta and was our client on the project. So if there's any questions there.
Cillian, we got a bunch, so
okay.
I'll queue it up. But I think this is just an amazing project, and there's a lot of discussion about the price and the objective. And I think you kind of wrapped it up in the last little bit of like, this is a prototype for bigger things, and I cannot wait for you to come back in a couple of years here to talk about the Canada Earth Tower and the lessons learned, and the fact that we'll have a mass timber passive house. So Kirk and everyone at the Delta Land Group, thank you so much for putting in all the effort to not only put this project together, but to showcase kind of as BC is beyond code. I'm stealing that from Mark, and it's exciting to see the innovation and all the ideas dumped into this. So the team that worked with Cillian on this is bravo to everybody. Okay. Ready for questions. We're going to skip Harvey because Harvey wanted to know the price per square foot. So we're going to hold off to the after hour to answer that question. And we're going to head over to Damien.
Great presentation and a fantastic project. I was just wondering, the isolation of the building from the ground, obviously allowing cold air underneath it. What drove the decision?
A couple of things, I guess. Am I still unmuted? I think I am. Yeah, so that's fair enough. You do get a penalty. I guess your boundary conditions are worse not being into the ground. Originally, we wanted to completely raise the building up off the ground. There was a lot of talk at early stage about it potentially even being a more temporary building. That wouldn't, stay there permanently. There was also talk about maybe pursuing the living building challenge and just minimizing. I guess there was a drive to minimize impact on the landscape and not like dig completely into the ground. And also to get up to a level to get the view, it sort of suggested that the platform be at this level and the living areas be at that level. And minimize, say, the amount of concrete on the building as well. So that sort of drove that design decision to raise it up. Once you do that, then you have a soffit that you then have to insulate and wrap, and you have cold air underneath, as opposed to say 10 degrees Celsius earth below you. So that did penalize us from, say, the soffit versus being a slab on grade. I remember looking at it. It wasn't huge. It wasn't, say, as significant as some of the other moves, but it did have an impact.
Thanks for that.
Thanks, Damien. Hope you're well. I hope Thursday's treating you well. Next in the line is Scott Kennedy.
Oh, just a simple question. I was curious as to the choice of mineral wool versus using like a blown cellulose or something like that on the outside.
We use a lot of mineral wool on our larger buildings, I guess, and we approach this as an assembly, for a part 3 building. So, for a mass timber building, we were thinking it's going to be, CLT, maybe sheeting layer, membrane, and then external insulation of mineral wool with the thermally broken cladding attachment. BC Passive House very much wanted to push us towards their typical part 9 or single family construction, which is essentially not a SIPS panel, but like a blown in cellulose approach. Not to say that we necessarily made the right call, but I think that's what the driving factor was, certainly at the time. We also wanted to put wood fiber board on the outside, but couldn't get Sean on the phone at the time.
Yeah, unfortunately, the price for that assembly was cheaper than what I could get, so I didn't bother giving him an estimate. So maybe the next one. Great stuff. Thanks, Scott. Moving along to Shelby and William is the next team in the queue.
Yeah, we had a quick question on the super remote area that this project is in and the difficulty that you might have come across in getting those massive panels on site. Were the roads easily traveled by a large semi-truck, or did you have to go through some rather challenging methods to get all those massive panels there?
I can let Kirk weigh in a little bit on this. We did have to, and part of our design process was essentially design a road up to the site, and clear some trees that went back into the lumber sort of supply chain, and part of the decision on where the road would go was to do with access and what truck could come up. BC Passive House had a staging area lower down, and then I guess Kirk, you can maybe chat about some of the accessibility challenges on the site.
Yeah, thanks Cillian. It's 6 kilometers up a fairly steep and treacherous Forest Service road, so we left it up to BC Passive House, who acted as our construction manager, to work out the logistics. And actually, I was blown away by the mastery and skill of these truck drivers and what they're able to do. I mean, they were bringing full tractor trailers up and backing them up a very steep and narrow gravel driveway. And we had a tower crane on the site, and yeah, it was really spectacular to see them operate in those conditions. And we also were able to, we did the foundations in the summer of 2018, and then we put the tools down for the winter, and then started up again in about April 2019. And we were able to actually maintain the road all the way through the winter of 1920 and continue work. And that was sometimes entertaining and eventful. We had a few cars sideways here and there, but thankfully everybody came out unscathed. And yeah, we just plowed the road and sanded it and kept going.
Yeah. Okay. Cool. Thank you. Yeah.
Thank you.
Kirk, while we got you on, do you want to talk about any comments, lessons learned, and just things that you're happy about with overall the project? Just love to get some of your insights on it.
Yeah, I mean, I guess a lot of people ask us, like, why did you do this? First of all, like, I mean, we're a property developer, we're a for-profit company, but we've had this 485 acres up in the Sioux Valley for about 12 years, and it's kind of a unique situation because it's the only 2 privately held lots in that whole valley. The rest of it is Crown land, so it is very remote from that perspective. There's no neighbors, or there's no possibility of any sort of peripheral development. So part of it was just, look, we have this land up here. We're trying to determine what is the best use for it. So let's build something to get more acquainted with the property and the seasons and what it's like getting there, and what's the experience of existing within that valley. And then at the same time, as we've embraced this kind of new direction towards high performance net zero building, why wouldn't we then take the opportunity for ourselves and our whole team, all of the consultants and builders and suppliers, to run a bit of a proof of concept and really try to learn from the experience on a small scale where the consequences are are not so severe or risky. It's not a commercial development. We're not selling it. We weren't sort of faced with externally imposed deadlines and warranty considerations and all that sort of stuff. So it was a really perfect sort of coming together of circumstances that enable us to learn about this type of building for the first time. And then also showcase, like it's going to be used, I'm sure, once we're allowed to get people up there, as a way also to demonstrate to our customers, our home purchasers and our commercial tenants, that you don't have to pay a price in terms of function and aesthetic to embrace this type of building. And in fact, it's much more resilient, it's much more robust, it just feels better and higher quality. So there's a bit of a marketing angle that we can leverage on that as well. As I said earlier, just an opportunity for the whole team to learn. But it's been really good. You know, I used to be a very devout steel, glass, and concrete minimalist type of person in terms of my aesthetic sensibilities, but I'm kind of sold on it now. Like the mass timber, you can see from the video, it's like if you don't like wood, you might have an issue, but it's just a really nice space to be in. And of course, the passive house element, it's just the wall thickness beyond the performance metrics. It's just the perception of that quality just comes through with, you know, the wall thickness and the acoustic performance and everything else. The only thing I would be critical of, as Cillian alluded to, is just the way the measurements are done. Like I really was a bit discouraged by the fact that we weren't able to achieve full certification because of the fact we had a double volume space. And if the calculations of floor area hadn't included the, you know, invisible floor that spanned across that double volume space, I think we might have just nailed it. So that there's always some tweaking, I think, that can be done on the certification side, but otherwise it's been a great experience for us.
Lloyd made a comment too, is, you know, why don't you just get rid of the mountain? Don't worry about the double height, just get rid of the mountain that was blocking your sun.
Get the bulldozer.
Anything's possible.
Yeah.
Sure.
No, Kirk, it's just a fantastic project, and I think we really appreciate that this project is setting you guys up for, you know, 10, 15 years with multiple projects. And as you go from the small, medium, large, and Cillian, when do you add the XL version to that timeline? So
we'll get through medium next, and then we'll go large, and then we'll, I guess, I mean, XL could be just loads of any one of them.
Yeah, exactly.
Replicated. We have, just as I'm talking, I think Zach has a like drone footage that I can play in the back. We can play in the background as well, just to give a better or another idea of sort of the context. So there's no sound or anything. It just plays in the.
Great, leave it there. Going back to more questions again. Thanks, Kirk. We'll probably come back with you with a couple more questions. But Joe from SMT Vancouver had a question. He's next.
Thanks for like such an interesting presentation. I was just wondering about the embodied carbon and sort of how that's measured and whose role on site and how that's all calculated really to get your kind of ultimate result.
It's becoming more and more in focus, I guess, on a variety of projects. And City of Vancouver is putting in policy requirements that you do it. So it's measured at design stage. It's not like passive house where there's more stringent metrics. A lot of places are just measuring to see where they're at. So we weren't aiming for any targets, I guess. Certain choices and design moves, like reducing the amount of concrete and steel, sort of led us to a lower embodied carbon and sort of maximizing timber. Once you have quantities of material, you can then do a calculation. There's a variety of softwares like Athena or EC3 or Tally. Some of them plug into your Revit model or other softwares, and it basically takes your material properties and it gives you an embodied carbon calculation. So we did that for this project, and we do it now for quite a lot of our projects. Perkins will have published an embodied carbon white paper, so there's a lot of information there as well if you want to learn more. But I think people are quickly, like the RIBA in the UK have issued actual values that people have to hit, but there's not at the moment, there's no real values you have to hit. People are just measuring it to see where they end up. I don't know if that fully answers your question. And then it's separate on the mechanical side. You have to do like refrigerant calculations. They're slightly different.
Joe, you good with that?
Yeah, that was excellent. Thank you very much.
Perfect. Lindsay Klein in New York City, you're up.
Thank you, Sean. Kirk mentioned acoustics, and that was actually what my question was. The interior face of those wood panels almost look like they were acoustic panels. Were they?
Byproduct, I guess, of just the nature of the panel, you would guess, I guess, an acoustic, the right word, attenuation, due to the ribbing. I'm not sure. I don't know if it necessarily. I'd have to check more in with Derek and Alicia if that came up as a particular design item. But yeah, it's particularly, I guess, in passive house projects. It's funny, not on this particular project, and not to divert your question, but we have an interesting dilemma on UVic, our student housing project, where PHI has mandated the HRV system has to be a certain decibel, and our acoustic consultant is saying it has to be a higher decibel because it's too quiet and there's too much background noise. But the passive house is so quiet and the HRV is so quiet that the acoustic consultant is afraid of all the background noise from the student corridors are going to spill into the bedroom. So now we have to artificially pump up our HRV white noise sound to satisfy. So it's a funny dilemma, but I guess it particularly when you have these more insulated and airtight buildings, you do have more sort of acoustic does become either a comfort or a nuisance criteria that you need to pay more attention to, I guess.
Yeah, well, I definitely agree with that. And just for 1 second, going back to the first part, the wood really, I guess it's just the reveal between the pieces, but it almost is as you're looking toward larger buildings and lobbies and so on, that really could actually be an acoustic panel.
I know we've done like on soffits before where you have a wood, like it may be DLT or maybe some other wood product, but they do deliberately put in like reveals for acoustic sort of mitigation. Yeah.
But I also completely, at some point, this whole issue of acoustics in passive house is so sensitive because you don't have a mechanical system per se, so that's not your struggle on this project, but it is a huge struggle on many other projects where conventional ductwork, even acoustically lined ductwork, isn't sufficiently quiet to prevent noise from traveling through it.
Yeah, that makes a lot of sense.
Thanks, Lindsay. Moving along, Tommy in Charleston.
There we go.
There you go, Tommy.
All right. Great presentation for a great project. My question is, what drove the decision-making for using what mass timber technology, where you used it? Was it, how much of it was technical? How much was it aesthetic?
Cillian, maybe I'll answer that quickly, is sometimes the suppliers can't take care of you, so they got to go to different products. So go ahead, Cillian.
Yeah, and so and some of it is structure, I guess. I think we originally had like CLT floor, and structural engineer sort of drove us towards NLT on the main floor because it was doing a lot of work. We originally had CLT walls, and then we became aware of the DLT panels where there's no mechanical or adhesive fixings. So some of, you start off with, mass timber, and then as you progress, you become a little bit more informed, or, either through your own learning or through, somebody else like the structural engineer telling you this is a better application. So that it sort of naturally evolved that way, I would say.
And I would add, Cillian, that, part of that ability for us to sort of test out different solutions drove us to try to throw in as many different mass timber assembly options as we could without being silly about it.
Great, thank you.
Scott Kennedy, back to you. I think you might have asked this because you had a couple in the queue and I didn't queue things up there. So did you have another question?
No, I think I'm good. I'm thinking good. I do see one about CLT versus DLT versus NLT. Somebody wants to know the answer there.
Yeah, I'll type that in the.
Sure. Here, I'll type while you answer. So Lloyd had a comment too, again, just about blowing out the mountain to help out with the calculations. Bronwyn Berry is next.
Hey, Branwyn.
Nice project, Cillian. It's great to see. My question was regarding the amount of glazing and whether that was something you looked at for, you know, you wanted to remove the mountain and the double height, and you had like 4 panels of glazing along the side, and I wondered, like,
yeah, we did at one
is that an
stage.
aesthetic, more aesthetic?
Yeah, we did at one
driven?
stage look at completely opening, say, the south facade more, you know, try and let in as much sun as possible. I guess, you know, that original passive solar approach. We knew we wanted PV there as well, so there was a little bit of a balance there. The more window you put in, the more PV you lose, but also we knew there was potential for overheating problems as well. So we probably could have introduced a little bit more south facing glass, but it wasn't giving us enough. Like, we could put in another bay or extend the bays we had a little bit, but it wasn't given. We weren't getting enough sun at the right times for it to be meaningful, if that made sense. We would have had to, you know, and it comes down to, you know, I've had a lot of discussions with designers and architects internally here that sort of, you know, that when they first encounter passive house, they find chasing the artificial 15 number frustrating. You know, oh, you can't put in a north facing window, you can't do this, you know, you can't do that. In this project, we probably could have hit 15 if we didn't have a sloping roof, if we had a flat roof, no double height space, no northeast glazing, and we're a bit no north glass, and we're a bit more paid more attention to south facing windows. You know, but then, you know, it would have been a completely different project as well. So, and I think part of what the plugin, the PHP work with Grasshopper, I think would help, is that there is some parametric design you can do with PHP with the variations, but it's a bit slow moving. Whereas, you know, some of the work with Grasshopper, it's quite automated. You know, it'll actually tell you, you know, you can run it X number of times and it'll tell you, you know, if you actually do this with your south glazing and do this, you know, you get a bit more of a direction rather than you coming in with the subjective point of view that you're trying to prove, and you can only maybe do 2 versions of that or 3 versions before you run out of time or fee to explore it further, if that makes sense.
Yeah, no, absolutely. I think kind of what I'm seeing is oftentimes actually people always think adding windows helps them, but actually what I've often seen that removing them can also help just as much. It's kind of this interesting balance point, and I think that parametric exploration would be much better if we had like slightly more dials that we could move more quickly. But it's coming, I think. I'm seeing good signs of it happening.
For sure.
So yeah, nice project. Thank you.
Very, yeah. And I guess too, Cillian, is, you know, we talk about the dials is just experience. You know, that's the best dial, is people being able to figure out, okay, you know, let's not just do 25% glazing, but maybe it's 22.5, and that's works. Going to go head over to Zach for some updates.
All right, excellent. Well, before I do the updates, I want to pause and thank our sponsors. None of this work would happen without our sponsors. So I want to encourage everybody to support these fine organizations and practitioners and manufacturers. So our founding sponsors are 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minotaur, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, StoCorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are BR+A, Brennan Insulation and Airtightness, Innotech Windows and Doors, and T-Stud. Next week, at our Passive House Accelerator Construction Tech on Tuesday, we will have Emily Aria and Lindsay Elton from Eco Achievers speaking about the red door of truth and the role of air barriers and blower door testing in construction practice in high performance building and passive house. So don't miss that, please, on Tuesday of next week. And then Wednesday next week, we have Lois Arena, who will be joining us from Stephen Winter Associates. She's going to be talking about the lessons learned that they have, they're unearthing from their application of VRF systems in multifamily buildings, and some important pitfalls to avoid, and again, lessons learned and experience to share. So one of those opportunities to learn from a pioneer and make sure you're not making mistakes that we can all avoid. So it should be great. Please join us next Wednesday. And with that, back to you, Sean.
Thank you very much. Prudence, did you want to say good night before we hop over to the after hour?
I do, and I'm a little sad because I'm not going to actually be able to hang out with you guys tonight. I have one last move left, so I've got to pack tonight, but I will see you all next week. I hear someone laughing. It's not funny. Don't laugh. Anyway, thank you so much, Cillian, for joining us. We're very happy to be learning from you, and I hope that you all have a great after hour. Have one on me.